Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 7th graders out there, though all students are welcome to tune in. Today's lesson is the 15th in our series. My name is Kayla Anderson, and I'm an 8th grade math teacher at Rocky Fork Middle School in the Rutherford County School System. I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them online at www.tn.gov/education. That's also where you can find the optional student packet. If you haven't seen any of our previous lessons, you can still tune in, but it may be more fun if you first go back and watch the other lessons, since today we'll be reviewing material that we've learned previously. Today's lesson is about applying proportional reasoning in order to solve problems. Before we get started, to participate fully in today's lesson, you will need paper, pencil, and a surface to write on. Okay, let's get started. We've been working quite a bit with ratios over the past several lessons. It may be beneficial for some review time prior to today's challenge. From the previous lessons, we've learned what proportional relationships, unit rates, and constants of proportionalities are, along with how to write equations using that very valuable information. What do you remember about proportional relationships? Go ahead and write down your thoughts. Well, let's talk about it. Two quantities are in a proportional relationship if all the ratios that relate the quantities are equivalent or equal. What's that? Right. If you graph a proportional relationship, it passes through the origin. Remember that the origin is 0, 0. Great job. Okay, so what do you remember about a unit rate? Go ahead and write down your thoughts. Okay, so a unit rate is a very special ratio that has a 1 in the denominator. And remember that the denominator is the number that's on the bottom of the ratio. Okay, so here's the last one. What do you remember about constant of proportionality? Write down your thoughts. The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y to x, and it is represented by k in the equation y equals k times x. So the constant multiple that relates proportional quantities x and y, the value of the ratio y to x, and it's represented by k in the equation y equals kx. Today's lesson is going to focus on applying proportional relationships in order to solve a variety of problems. This is going to be a really fun lesson because we're going to take what we've learned in the previous lessons and apply it to real-world problems. Can you think of a place where you have seen ratios or a proportional relationship? Maybe at your home or somewhere at school? I hope you were able to come up with a couple examples. I think of proportional relationships every time I have to stop and get gas for my car. The sign out front usually says the price per gallon, and that's a unit rate. Ratios and proportional relationships are very helpful. So let's solve some problems together. Okay, so here's our first problem. The ratio of collectible cards Deshawn owns to cards that Stephanie owns is 5-2. Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Explain your answer. Make sure that you're working the problem on your paper as I work it out here in front of you. So what do we know from the problem? Right, we know a ratio. Okay, so what is the ratio of Deshawn's cards to Stephanie's cards? Right, it's what I just circled. The problem says the ratio of cards that Deshawn owns to cards that Stephanie owns is 5-2. Okay, so what does the ratio actually mean? Right, so it means that for every 5 cards that Deshawn has, Stephanie has 2 cards. Okay, so how many cards does Stephanie currently have according to the problem? Right, she has 36 cards right now. Okay, now that we have that important information and we've taken that from the text, we need to figure out how many cards Deshawn has before he sells half of them. So we know the ratio, we know how many cards Stephanie has, we need to figure out how many Deshawn has before they've sold any of them. So can you figure out how many cards Deshawn has before he sells half of them? Well, the ratio is very important in this problem. If the ratio is 5-2, then we are able to set up a proportional relationship. So if I have the proportion, or the ratio of 5-2, remember that is 5 cards that Deshawn owns for every 2 cards that Stephanie owns. So now, to set up our proportion, do we know how many cards Deshawn currently has? Right, we do not. So we're going to use a variable to represent that. How about the number of cards that Stephanie currently has? Sure, we do know that. We know that she has 36. So make sure you've written that on your paper. Again, where did that 36 come from? Right, it's the number of cards that Stephanie currently has. And the variable x represents what we're trying to solve for, and that's the amount of cards that Deshawn has. So how can we solve for the variable? How can we isolate x in this equation? Well, x is being divided by 36, and when we solve equations, we use inverse operations. So what's the inverse of dividing by 36? Right, we're going to multiply by 36. So if we multiply both sides of the equation by 36, okay, multiplying here, 36 times 5/2 is 90. And multiplying by 36 here, we get x. So 90 equals x. So using that equation, we calculated that Deshawn currently has 90 cards. So now that we have that information, we can write the ratio of 90-36 because we know that Deshawn has 90 cards, that's what we just solved for, and Stephanie has 36 of them. Okay. The problem says that both Deshawn and Stephanie are going to sell half of their cards. So now we have to find the new totals. How can you find the new totals if they each sell half of their cards? Right, again, we're going to divide 90 by 2 and we're going to divide 36 by 2. So because they're selling half of their cards, we're going to divide 90 by 2 and 36 by 2. What'd you get for your new ratio? Well, I hope that you have 45-2. 18. So the new ratio is 45 to 18 after both Deshaun and Stephanie sell half of their cards. Okay, so now we're going to simplify this ratio. What number goes into both 45 and 18? 9. 9 is a multiple of both 18 and 45. So we're going to divide 45 by 9, and we're going to divide 18 by 9. So go ahead and tell me your answer. Right, 45 divided by 9 is 5, and 18 divided by 9 is 2. So once they've sold half of their cards, and we've simplified that ratio, it's 5 to 2. The ratio did not change. Why do you think the ratio didn't change? Well, the reason it didn't change is because both Deshaun and Stephanie sold the same multiple of cards. Great job, folks. Here's another example of how to properly apply proportional reasoning in a contextual problem. Take a look at this one and make sure that you're working the problem with me. Martin is 6 years old when his sister Cassandra is 9 years old. How old will Martin be when Cassandra is 6 years old? Please make a table in order to represent this problem. Go ahead and do that now. Make a table. See if you can figure out your answer. I'm going to pause and give you some time to do that. And then once you've had a chance to make your table, we'll look at mine and work through the problem together. Okay, so here's an example of a table from the information that we were given in the problem. Do these values look similar to the values that you used? Okay, so from your table or from the table that we have here, how old will Martin be when Cassandra is 6 years old? Right, Martin will be 9 years old when Cassandra is 6. So we filled in the table. Cassandra's 3 when Martin's 6. She's 4 when he's 7. She's 5 when he's 8. She's 6 when he's 9. So does this information represent a proportional relationship? And then why or why not? I'll pause while you figure that out. So this one does not represent a proportional relationship. If you think through proportional reasoning and looking for a constant multiple, there is no constant multiple in this one, so we can't apply proportional reasoning. Notice that if I were to take Martin's age from the original number that we started with in the problem to what we were trying to figure out, I can multiply by 1.5. However, if I multiply Cassandra's age from the beginning of the problem to the end of the problem, I'm multiplying by 2. So 6 times 1.5 is 9, but 3 times 2 is 6. So because these are not the same multiples, it's not a proportional relationship, and we can't apply proportional reasoning. Good job. So you've been doing a great job helping me through these problems, guys. Let's look at another one. A video streaming service charged Brian $143.84 for a full year of access. According to the company's ad, the video streaming service costs $8.99 per month. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? For the first step, can you create an equation to represent the scenario? I'll pause while you do that. Create an equation to represent the scenario. What equation did you create? Since the rate is $8.99 a month, a possible equation is y equals $8.99 x. Does that one look like yours? All right. So what do the x and y variables represent in the equation? Right. The y variable is the cost after x amount of months. Since Brian has paid for a full year of service, how many months should he have been charged for? Correct. There are 12 months in a year, so Brian should be charged for 12 months of service. What variable should we substitute the 12 in for? Should we substitute 12 for the x variable or for the y value? Or excuse me, for the y variable? Right, x is the right variable because x represents the number of months. And we know it's been 12 months. We're going to substitute 12 in place of x. So y equals the $8.99 per month. He's paid for a full year, which is 12 months. Make sure you're writing this down. When we do the multiplication, y, which is the cost for the number of months, is $107.88. So what does that mean? Yeah, it means that Brian should have been charged $107.88 for a year of streaming services, but he was actually charged $143.84. So what should Brian say when he talks to customer service? Yeah, he should definitely ask for a refund, but how much of a refund should he ask for? Can you please calculate Brian's refund now? I'll pause while you do that. Okay, so to calculate this refund, we have the amount of money that Brian was charged minus the amount of money that he should have been charged. And that leaves us with $35.96. So Brian should definitely tell the customer service that he would like a refund and that his refund should be $35.96. Awesome. Thank you for helping me out with that one. Here's another one. Oops. There we go. Marco needs to buy some cat food. At the nearest store, 3 bags of cat food cost $15.75. How much would Marco spend on 5 bags of cat food? Okay, so what would your first step be in order to solve the problem? Right, we need to calculate a unit rate price to see how much it will cost for 1 bag of cat food. Go ahead and calculate the price for 1 bag of cat food now. So did you divide $15.75 by 3? Great, because that's what you should have done. So what did you get for your unit rate? Remember that a unit rate has 1 on the bottom. This was the price for 3 bags of cat food. We needed the price for 1 bag of cat food. So $15.75 divided by 3 gave you $5.25. So it cost $5.25 for 1 bag of cat food. Now, if we go back to the problem, it tells me that Marco needs to buy 5 bags of cat food. We've already solved to find the unit rate, so now let's create an equation. So go ahead and write yourself an equation using your unit rate or constant of proportionality. Make sure that you're using x and y variables so that when we check our answer, you can make sure yours is the same as mine. Okay, so does your equation look like that? Awesome. You could have parentheses around X if you would like to. So $5.25 is that unit rate or the constant of proportionality. So if Marco needs to purchase 5 bags of cat food, then which variable are we substituting the 5 for the X variable or for the Y variable? Hope you said for the X variable, we're going to substitute 5 in place of X. So go ahead and do that now to figure out how much Marco would need to pay for 5 bags of cat food. All right, so when you multiplied $5.25 times 5, did you get $26.25? So now he knows how much money he needs to take to the store. Okay, so here's another one. A recipe calls for 15 ounces of flour for every 8 ounces of milk. Is the relationship between ounces of flour and ounces of milk proportional? Explain. So what do you think? Is this proportional? And can you explain why? I'll pause while you think about that. Okay, so what do you think? Is it a proportional relationship? Yes or no? Right, it is proportional. So yes, it is proportional. But then we need to explain why. So why is it a proportional relationship? Well, it's proportional because you can write the equation y equals 15 over 8x, where 15 over 8 is the ratio comparing the ounces of flour to the ounces of milk. So because that ratio of 15 ounces to 8 ounces is our constant of proportionality, and we can write it in this equation, it is a proportional relationship. So what if the recipe calls for 15 ounces of milk, and we want to know how much flour should be used? So a recipe calls for 15 ounces of milk. How much flour should be used? Go ahead and use the equation we just wrote to solve for the amount of flour. I'll pause while you do that, and then we can check our answer together. Okay, so using this equation that we have here, we're substituting, remember the X represents the ounces of milk, so we're substituting 15 ounces of milk to figure out Y, which is how much flour. Doing the multiplication there, you should get 28 and 125 thousandths. So what's that mean? Exactly. It means that 28 and 125 thousandths ounces of flour are needed. Great work today, 7th grade. Today we worked on how to use constants of proportionality in order to solve some problems and write equations. You really did a great job today. After the video is over, you are going to have some problems to practice on your own. I'm going to show you those independent practice problems now. Here they are. You can also find them in the student practice for this lesson, which is posted on the website www.tn.gov/education. Good luck on those and do your best. All right, folks, I really enjoyed reviewing how to apply proportional reasoning in order to solve problems with you today. Thank you so much for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning series. Bye.